All right, hi folks. So we're going to jump into a little presentation to kind of maybe clear up the whole idea of what is flexo. So let's jump into this. So flexo is the process of producing a huge range of packaging products like flexible packaging, labeling, folding cartons, bags and pouches, and also corrugated boxes. So these are some of the major market categories that Flexo really caters to. There are other things that could be printed by Flexo. I mean, I have seen magazines that are printed that way. I have, envelopes are commonly done that way. A lot of junk mail is done that way. Also, things like some like newspapers, a lot like Charlotte Observer is still printed by Flexo. Things along those lines. Even things like phone books, which nobody uses anymore, but that is an option. So, yeah, but these are the main things that when we talk about Flexo, these are the things that we're talking about, and these are the areas in the world right now that are in a lot of demand. And that's something to really understand is that right now in the world, these markets right here are growing at a fast rate. People are buying more consumer goods. And if you think about it, when I say consumer goods, I mean, these are things that people buy, they use, and then they discard. You know what I'm saying? Like everything from food products of sorts to toiletries to you name it. Basically, if you walk into a Target or a Walmart, you're most likely going to purchase something that was printed by Flexo. And when I said Target, one thing that popped to mind that actually is pretty big that I'm not mentioning here is tags. Things like tags, like anything that could go on, like tags for clothing, any kind of tag is also a pretty big market that maybe I should have put in the list as well. But let's move along and kind of look at each one of these a little bit better. So when I talk about flexible packaging, that's a very broad term, but what we're referring to is literally the material that things are being made out of. This is like paper, plastic films, metallized foils or laminates. These could be used to package things like snack foods, perishable foods like bread bags, and/or pharmaceuticals. So these are products that you handle on a daily basis. I mean, when you guys are in class, I see you guys eating your snacks that come out the vending machine. Everything out of that vending machine, moved through a flexo press at one point or another. Labeling is a huge area that Flexo really dominates. Labeling, serves a number of purposes. Everything from being decorative to informative. But I guess really any packages can be decorative or informative. Most labels are printed on pressure-sensitive stock, which can be film or paper. And when we say pressure-sensitive, that's a good term for the day. Pressure sensitive. That is, for lack of or for an easy way of expressing what it is, it's essentially, sticker material. We don't like to say stickers because we don't print stickers, we print labels. But, think about it. It's got a printable surface, and then it has adhesive that is already on the back of it. That's two layers. You get the face and the liner. So it's basically just a material that you can print on, that you can punch shapes out of, and then you have a ready to go label. Now labels don't always have to be pressure sensitive. They could be printed directly onto, let's just say, paper, and then an adhesive is applied to the label before it is adhered to the product. So labeling's huge. Folding cartons, folding cartons is essentially by using a paperboard substrate. So paperboard is essentially paper with extra physical characteristics like density or thickness or weight. So these are printed, and then once they are printed, they are converted into a carton of some sort, and we get all kinds of products in these sorts of containers. Everything from like cereal to donuts to snacks to pharmaceuticals, office supplies, and possibly even games. Bags and pouches. This is an area that has really kind of exploded in the last few years. What they do is they use a wide variety of substrates, from natural craft to bleach fiber to clay-coated paper, or a variety of films and foils. So I keep using the term substrate, and just so you know, the term substrate is essentially whatever type of material that we may be printing on. It may be paper, it may be a plastic film, just anything that we're printing on is called a substrate. So that's another good term for the day. So pouches are really growing in the industry today, and one of the main reasons for that is they say that it is more environmentally friendly than using a carton. So, like for example, when you look at like this little bag of candies right here, now it's, instead of printing it on a folding carton, they're putting it in these pouches, and they're saying that that is more environmentally friendly. Well, and the reason they say it's more environmentally friendly is because a pouch can take up less space than a folding carton. That's what they say. And so since it takes up less space, you can pack more into a box. It can be distributed faster and easier. Less gas mileage. Those sorts of things occur with pouches. But another way of thinking about this is that a folding carton is made out of paper, and paper is recyclable. Plastic films like this are not. But the thing to understand is that these bags and pouches and such are they're very user friendly. They're very convenient to use. We can put very high-end graphics on them, and there's a lot of ways of varying up the substrates so that what you get is a really nice looking label. So those are pouches and bags, but also what could fall into this category would be things like shopping bags. Even you think about how many Walmart bags are printed and used on a daily basis. I mean, there's millions of them that are used every single day. So there is a big demand for this. There's a lot that can be done with bags and pouches. Corrugated boxes. Now the thing is that corrugated really is something that lends itself well to the flexographic printing process. Other forms of print are not, a lot of times other forms of print will damage the structure of that substrate. So when you think about corrugated, why don't you just think about cardboard? So when you look at the side of cardboard, it's got that little wavy structure that's going on there. Most printing presses would crush that structure, and whenever it transfers. But with flexo, due to the nature of it, and us using like it's not rubber, but like a rubber-like plate that has some give to it, it prints very well on these types of materials. And I can imagine if you have if you have an Amazon account, you probably are seeing quite a bit of boxes like this, especially after Christmas time. So if your recycling bin is full of corrugated boxes, well, you could definitely see how it's a big need in the world. So let's talk about, what is a flexo press and whatnot. So the thing to understand about a flexo press is that, and what kind of differentiates it from other forms of presses, is that it prints from one roll to another. It doesn't necessarily have to go to a second roll, but it almost always will come off of a roll, and then it moves through the process. So we'll start at the beginning of the machine where we have our unwind area, and this is where our roll would go on to. It's going to deliver the material or the substrate to the printing press. Some other things that will happen in this area, there will be parts on that will control the tension on the web as it moves through. We call the web the path that the substrate will go through the machine. Things like tension as well as alignment of that web will occur at this area. At the end, you'll have a rewind station where essentially it will rewind onto a roll again. Other things could occur at the end. I mean, you could sheet it. It could be going into sheets. There could be a blade that chops it at the end. But that's going to be the rewind area. Also, we're going to have our print stations. This is where the magic, so to speak, happens. It's where the ink is going to meet the substrate. So each station is going to represent one color or one ink that is being printed on the machine. Animation. So in between each print station, we're going to have dryers, and those dryers can come in a variety of different forms depending on the types of inks that we're using. It could be forced air that blows warm air over the web to dry the inks. It also could be some technology called UV curing units, and it uses a special type of ink where UV light converts the ink to a solid. Very neat, and some of the higher end and most higher end printing presses would have the UV curing technology. Down here at the end, we have or close to the end, it's going to be our online converting area. And at this stage, there is quite a bit that occurs. You could die cut, you could perforate, you could slit it, you could add laminate to it, and that's one of the major advantages to a flexographic press is being able to do all of those accessory type things right there in one area. You can also add things like foils or films that will go over it to give it a special effect of some sort. So I'm going to kind of repeat myself real quick, so I'm going to kind of go through this fairly quickly. So, the unwind station of the press, we can kind of see some of the images that are popped up. It's just basically the beginning, kind of reiterating some of the things that I previously said. The rewind section, it's the end of the press. So you got to think about this, that it's also what drives the substrate through the press. That's where the pulling mechanism is that pulls it through. You can't really push paper, so you got to pull it through the machine. And then, so what this does is it makes sure that it's moving properly through the press, but also is the space where it is rewound up into a roll. So one of the things to kind of understand on a flexo press, that tension, how taut is it being pulled? It's balanced by two forces that are in the press. You have a braking force at the beginning, so there's essentially at the unwind area, there's a brake that you can control that makes that pull harder to pull, and that increases the tension on the substrate. And then also you have the pulling force at the end. So if you need more tension, you can turn it up at the end as well. So it's about balancing these two things. Jumping into kind of some of the parts of the printing station, there's usually 4 rollers that are in there, and we're going to get into what these rollers are, what they do in a little bit more detail later on. But what you need to understand is that there is an area that holds the ink. There is a roller. Usually there's a roller in the ink. It's called the metering roller that picks up the ink and then transfers it. It goes to a very, very special roller called the Analox roller. And what the Analox roller does is that it's what keeps the amount of ink getting to the plate stable. So it's a roller that has millions of tiny little cells all over it, and those tiny little cells pick up a measurable amount of ink that can then be transferred to our plate cylinder. And then lastly, there's the impression cylinder, which is what the plate so the substrate runs over the impression cylinder, and it gives a backing for the plate to push up against. Oh, and then yeah, I've got some animation in here as well. So here's a little bit of a better view of things. So over here, we've got the metering roller here sitting in the ink pan, picks up the ink, transfers it to the Analox cylinder. There's a little blade that will shear off any excess ink here. And then once there's that measurable amount of ink that's in those cells, it'll get transferred to the plate, and the plate will transfer it directly to the substrate with the impression cylinder, just giving it something to push up against. So the thing is when this starts off, there's a lot of ink that is being transferred to the Analox roller. As you can see, I mean, that's just a gross amount. You've got the metering roller here that picks up the ink, transfers it to the Analox roller. That is why we need to incorporate a metering system into it, and we'll talk about that in just a second. But like I said, with the Analox roll, it's designed to transfer a precise amount of ink to the plate. It's laser engraved, ceramic coated, so it's got the ceramic coating that lasers go and pick out little tiny cells all over it. It works with the ink metering system, and basically is like how much ink that gets transferred is by the BCM, which is short for billion cubic microns, which essentially says, well, how much volume will each one of those cells hold? And then CPI, which is the cells per inch. How many cells are there in a square inch? So when we talk about ink metering, we've got a little funny stuff going on with the formatting of this particular slide. It is a two-roll system. There are multiple systems, but the whole point of it is to remove any excess ink. Here is an example of the most basic system. It just has the metering roller and the Analox. Then we have a single-bladed, what we call a doctor blade, that shears off that excess amount of ink right there. And then we have the chambered blade system, which is a little bit different. What it does is that it takes away the ink pan and the metering roller, and it creates this. This is also used whenever you need a very long run where it's going to utilize a tremendous amount of ink. Where what it will do is it'll pump ink into this little chambered area. There's actually an exit port for it so that it can maintain pressure, and it's just pushed right up directly to the Analox roller, and then it just passes by, picks up the ink, and then it gets sheared off. So it creates a kind of a dam in here by utilizing two doctor blades instead of just one. Okay, so here is a press in action. This is a two-roll system, and you can see what the operator did is that he just put a bunch of pressure on those rollers so that it kind of squeezes the excess off. Not the most accurate in the world, but does work. This right here is a system where that has a doctor blade. The doctor blade is right here, and it's shearing all that excess ink off of the Analox as it rotates. And then we have a chambered blade. this is a very old machine right here. I had a hard time finding any kind of video of a chambered blade system, but they're very commonly used. And but that machine, gosh, that looked like something ancient and scary. All right, so let's talk about the printing plate on a flexo press. So the thing to understand is that a flexo plate is like a stamp. All right, think of it like a rubber stamp. It's got a raised image and it is on a rubbery type of material. So printing plates are made out of what's called photopolymer, and photopolymer is kind of like a light sensitive plastic. It's made through a process of exposures and whatnot, and then that plate is wrapped around a cylinder like so, and uses a foam mounting tape. The whole reason for the mounting tape is that it's what keeps it adhered to the cylinder, but it also gives the plate a little bit of cushion so that it doesn't squish the image that is on the plate. And essentially, our artwork is raised up off of that plate material. So throughout the term earlier, substrate, just so you know what that is, and that is the material that we print on, and it can be a wide range of things. So I found something like when I went searching for some images. I mean, a lot of it is paper, film, and that's a huge word, but it could be anything. Like this right here is material for mouse pads. I didn't know that was still a thing, but evidently it is. It could be it could be a wide range of materials that are out there. So basically, that's one of the great things about Flexo is that you can print on just about any type of material. So if you can put it on a roll and it's not rigid, then you can run it through a Flexo press, and that's what really sets it apart from a lot of printing processes. That's not something you can really do with really any other form of printing. Now I mentioned that we use the mounting tape to hold the plates onto the cylinder. It's used. It's a foam tape with adhesive on both sides. There's different choices that you can make that will impact how the image on the plate reproduces. You'd use like softer mounting tapes whenever you have a whole lot more detail. Whenever it's if you have a lot of solid or bright, vibrant areas on a plate, then you would choose a harder one because they're going to transfer more ink. Plate cylinders, they come in a wide variety of sizes and such. And it's really going to depend on the size of what you are printing. So if you have something that, has a large area of coverage, well, it's going to have to wrap around a fairly large cylinder, and such. So, and one rotation of that cylinder is going to be, kind of the length of what you're printing on the press. So a lot of times these cylinders are referred to by the number of teeth that are on the cylinders. Like for example, we got some arrows that are pointing to like an 82 cylinder or a 71 tooth cylinder. These kinds of things reflect back to the circumference of that cylinder. One thing to kind of understand is in most instances, the distance from one tooth to the next is 1/8 of an inch, at least here in America. It's 1/8 of an inch. So that means that there's 8 teeth in 1 inch. So if you had a 96 tooth cylinder, it's going to be a 12-inch repeat. So a way to think about it is that if you have, if you know how many teeth are on the gear of that cylinder, let's just say it's 80, you can divide 80 by 8, and that would give you the correct length around that cylinder, which would be 10 inches. Another way to think about it is you could just take 80 and multiply it times 1/8 of an inch. I think dividing by 8 is a little bit easier in my mind, but whichever way works for you, that can kind of help you figure out the circumference around that cylinder. All right, so like I said, the impression cylinder. The impression cylinder is just there to add support for the web as the printing plate presses against it. It is generally a very solid, smooth, polished cylinder. It's very important that you keep this cylinder clean. If any ink gets on it or builds up, it can distort how ink transfers in that particular area. If you look at this image right here, see how there's that little bit of ink on the impression cylinder? That's something that needs to be cleaned off. But it's not really going to be a problem because the web isn't covering that area. But something to kind of keep your eye on. So here is a print unit, a little bit more put together, and so you can see what's going on here. You get your metering roller. Metering roller is going to transfer ink to the analox roller. Doctor blade is going to shear off the excess amount of ink. That analox roller is then going to transfer to the plate cylinder, and then there's going to be that impression cylinder that just helps and supports the plate cylinder pressing against it. So here we go. There's our analox roller. That's our plate cylinder. That's our impression cylinder drum. And then this one doesn't have a metering system because it is using the chambered metering system. Okay, so all right, what we're going to do is that I'm going to stop this at the moment, and so I can break this up into a couple parts.